Hey guys, this is lesson 1.3, Confidence in Measurement. We have two standards that we're going to cover today. The first one is justifying the choice of equipment used to make a measurement based on precision. And our second one is to record the measured values to the proper experimental precision. So making measurements correctly in chemistry is our goal today. Um, Even though you guys won't be in class to ever do that, it's still an important skill that we're still going to try to practice as best we can. Okay? So today, I want you to try to find some sort of measurement tool, a ruler, a measuring tape, a measuring cup, something like that. Okay? So hit pause and go do that. All right, now that you've come back, I want you to measure something with it. Record as many digits as you think is reasonable. How confident are you about each digit that you write down? You can estimate. Be careful in overestimating. And then record what you find here, right? So here's a Google Doc for you to record what instrument you found and what measurement you took with that and what you measured. Okay, and we're going to talk about that on Teams. So again, hit pause again and go back to Teams. All right, now that our Teams discussion is done, I want you now to go back and watch the Edpuzzle, which is on the 1.3 lab. So you have that handout, but you can also, it's an easy one to do electronically. You can just add those text boxes to your DocHub and write your measurements down from the Edpuzzle video, okay? Okay, so then we're going to go back to Teams to do our discussion. So if you will, we're just going to skip ahead from this part right here. So our main key ideas from the activity were that graduated cylinders are more precise because they have smaller increments of measure. Estimated values, when you take a measurement, is always one digit to the right on the increments to whatever tool that you're using, whether that being a measuring cup, a graduated cylinder, a ruler, a measuring tape. Doesn't matter what measurement you're making, you always want to estimate one digit from that instrument, okay? So because you make measurements with instruments, right, measurements are not perfect. They can only be read to a certain number of digits. You cannot read an infinite number of digits from a measurement. So that number that each instrument will read are called significant digits. The digits that each instrument reads are called significant digits. So when taking a measurement using a ruler or a graduated cylinder or a triple beam balance or whatever it is, you always read all the certain digits plus one digit of estimation, okay? One uncertain digit. So we're going to practice, okay? So what is this measurement? So maybe pause, take a moment, think about it. You have a red paper clip, and we have not a very good ruler, but what would you say that measurement is, right? So I can be certain about the 2, okay? And I can be certain that over here is a 3, and I know that this paperclip has to be somewhere between 2 and 3. Now, it looks a little less than halfway, so I would probably estimate 2.3 centimeters. I know that I'm at the 2. I know I'm not all the way to the 3, so somewhere in between there, and as I'm estimating, it doesn't seem to be at the 0.5, it seems to be less, so 0.3 sounds reasonable to me. So I'm going to go with 2.3. Another person might read that as 2.4, right? That's where you get error in your measurement because our tool is not very precise. But what if I gave you a better ruler? So now let's look at this image. The same paper clip, but with a better ruler, now what would we say the instrument can measure that length as? So as you look at this, you get the 2, right? And you can count over to the point 1, 2, 3, and then it's between the 3 and the 4 on those markings. So because it's between the 3 and the 4, now I can estimate. I'm for sure about the 2.3 now. And now I'm going to estimate one more digit. So now I would say 2.34 because I like 2s, 3s, and 4s. It makes a nice little pattern, right? Someone else might read that and think that it's more like 2.32. That estimated digit will wiggle, okay? It'll change per what person sees. And sometimes you'll see that happen maybe on a scale when you're weighing yourself. It's that uncertain digit, and the instrument is trying to figure that out as best it can, that last digit of estimation, okay? But you can do the same thing with any instrument, so let's try one with a graduated cylinder. Now, how we read a graduated cylinder is that you always want to look at a graduated cylinder at eye level, which you don't have. So you want to read these pictures at the bottom of the meniscus, not at the top. So that water will curve, okay? And as that water creates that curve, that meniscus, you want to read at the bottom of the meniscus, okay? So here you wouldn't want to read all the way at 37, right, which is what this would indicate. You would read the bottom of the meniscus. You know you're for certain about the 35 and the 36, so you know this is not quite the 37, 36.5, something like that. You would estimate one more digit than what the instrument reads. So because this instrument reads to the ones place, you estimate the tenths place. Okay? Let's go back. Because this ruler reads to the tenths place, you then have to estimate the hundredths place. Okay? Estimating one more digit is how we take a proper measurement. Okay? What about a mass? Right? So here we have a triple beam balance that reads 190, but not 91, so 190. And then I'm going to have to zoom in if I can. I don't think I can. On this image, okay? And so I know the 190, when I zoom in, it looks like, as far as I can tell, 190.4. Okay? And then I would have to still have a digit of estimation. So if I can read 0.4, I can point at it right here, right, with my arrow. Then I can estimate another digit. So that would be 190.41 or something like that. Okay? So then you can use measurements and also find the percent error in your measurements like we did in the 1.3 lab. So where can you find that formula? Why, it's on your yellow sheet if you picked up your documents. Otherwise, it's on your pre-AP formula sheets that you can download and print from the pre-AP website. So it says a student measures the volume of their unknown liquid to be 70 milliliters in a beaker. However, when they poured that liquid into a graduated cylinder, the volume was actually 72.4 milliliters because you get more precision with a graduated cylinder than you do a beaker. So what would the percent error for that volume be? So you would take your actual, even says the word actually there, so the 72.4 minus 70 is 2.4, divided by the actual 72.4 times 100. So that mathematical operation will give you your percent error, and you should be able to calculate that really easily. All of you guys have passed Algebra 1 with flying colors, which is why you're in honors chemistry. Okay? So our enduring understanding is that all measurements have uncertainty, that their level of precision must be accounted for in the design of an experiment and the recording of data. Okay? So now what I would like you to do is work on your measurement PL, where you will measure with triple beam and quadruple beam balances as well as graduated cylinders. And then also do the percent error PL, which is just a short 5-question quiz on Canvas. Okay, see you later.